Hello guys, here's some examples on solving systems of equations by substitution when the equations are all in slope-intercept form. So notice all of our equations here in both examples, they all start off with y equals, right? So all of these equations are in slope-intercept form, y equals mx plus b. If we're going to solve a system of equations using substitution when they're all in slope-intercept form like so, it's very easy to do that because if they're both starting off with y equals, then all we have to do is set the equation equal to each other and solve. So if this is y is equal to 7x minus 10, and then this is also y is equal to negative 3, and these are both y's, then I can just set these two expressions equal to each other and solve. So let's do that. In the first equation, y is equal to 7x minus 10. And then in the second equation, y is equal to negative 3. So I'm going to set 7x minus 10 equal to negative 3. Now I have only x in this equation, so I'm going to solve for x. And we're going to use inverse operations to do that. So I'm trying to get the 7x by itself. So to isolate that, I am going to do the opposite of negative 10, which is plus 10. So I'm adding 10 to both sides. That will cancel out, and then we're going to be left with 7x is equal to 7. And the last step here to get x completely by itself is to divide by the number in front of x. So we're going to divide both sides by 7. 7 divided by 7 is just 1, so that cancels out, and we're left with x is equal to 7 divided by 7 is also just 1. So x is equal to 1. Now that I have found my x value and I know that x is equal to 1, I just have to figure out what y is equal to. But notice, in this system of equations, it's already given to us, as we're already told, that y is equal to negative 3. So we don't need to substitute the 1 to find what y is because we already know that y is negative 3. So I can just write that down here. Y is equal to negative 3. I know what x and y is, so my solution to this system of equations is 1, negative 3. Right? This is my x value, that's my y value. And that's it. All right, in the second example, we also have y is equal to 2x minus 5 and y is equal to 5x. So since these are both y's, I can just set the two equations equal to each other, right? So 2x minus 15 is equal to 5x. And then we solve. So let's do that. In the first equation, we have 2x minus 15. And then in the second equation, y is equal to 5x. So 2x minus 15 is equal to 5x. We have only x's in this equation, so we're going to solve for x using inverse operations. So I want to move all the x's to one side. So I'll start by subtracting this 2x. This will cancel out. 2x minus 2x cancels out. And we're left with negative 15 is equal to 3x. 5x minus 2x is 3x. Last step here to get the x completely by itself is to divide both sides by 3. Okay, negative 15 divided by 3 is just negative 5. And 3x divided by 3 is just going to be x. So, negative 5 is equal to x, or x is equal to negative 5. I just like to rewrite it where my variable is on the left side. That's a horrible box. What kind of box is that? Okay, so x is equal to negative 5. Now that I know what x is, I need to find out what's the value for y. in this system of equations, we were not told what the value of y is. We're told that y is equal to 5x, but not a specific number value. So we need to find out what that is. So all we have to do, since we know what x is, we're going to take the value of x and substitute it back into this equation for x and solve to find out what y is. So we have y is equal to 5x. I just found out that x is equal to negative 5, so y is equal to 5 times negative 5. And all I'm doing is I'm plugging in this negative 5 for x. 5 times negative 5 is just negative 25, so y is equal to negative 25. So my solution here is negative 5, comma, negative 25. Okay, cool. Let's look at two more. So I have y is equal to 3x minus 5 and y is equal to 4x. Again, this is both in slope-intercept form, so since this is y equals and the second one is also y equals, I can just set these two expressions equal to each other. So I will have 3x minus 5 is equal to 4x. And now I just solve for x. So I will add 5 to both sides. Oh, I messed up my color. Okay. Negative 5 plus 5 will cancel out, and we are going to be left with 3x is equal to 4x plus 5. And then I'm still trying to get all the x's on one side, so I will subtract 4x from both sides here. 4x minus 4x will cancel out. 3x minus 4x is negative 1x, or negative x, is equal to just 5. Now, I did this a little bit longer than I should have because I wanted you to see that when we have a negative x, like so, we need to do an extra step here to get x completely by itself and for x to be positive. So when we have a value like this, negative x and negative 1x, to undo the negative, we need to divide both sides by negative 1, right? Because there's this 1 or invisible 1 in front of x. So my last step here would be to divide both sides by negative 1. This will cancel out, and we'll be left with x is equal to negative 5. Cool. Now that I know what x is, I need to go back and find out what's the value for y. In this one, we were not told what the value is for y. We know that y is equal to 4x. So I'm going to take my x value of negative 5 and substitute it for x and solve. We could also plug in the negative 5 for x into the first equation, but this equation is a little bit longer because we have to distribute and subtract at the same time, right? So it's easier to just plug in x into the second equation. It doesn't matter which one you plug it into, you'd still get the same y. So we have y is equal to 4x, therefore y is equal to 4 times negative 5, and all I did here was plug in negative 5 for x. 4 times negative 5 is just negative 20, so y is equal to negative 20. So my solution here to this system is negative 5, negative 20. Alright, and the last one, we have y equals 3x plus 6 and y equals 4x. Again, this is the same like the other, so I can just set the two equal to each other since they're both in y equals. So I will have 3x plus 6 is equal to 4x. Now I solve for x, so I will subtract 6 from both sides. 6 minus 6 will cancel out, and then I'll have 3x is equal to 4x minus 6. And just notice that these are not like terms, right? So I can't combine them. I can't do 4 minus 6. That's why I rewrite them individually in my new equation. So 3x is equal to 4x minus 6. Now I need to get the 4x over to the left side, so I'm going to subtract 4x from both sides. That will cancel out. 3x minus 4x is negative x is equal to negative 6. And what I wanted you to notice is, again, we have this negative x, and there is an invisible 1 right here. So to undo that negative, to get rid of that negative x, I need to divide both sides by negative 1. My negatives will cancel out, and I'll be left with x is equal to positive 6. A negative divided by a negative is a positive. So negative 6 divided by negative 1 is just positive 6. So x is equal to 6, and now I need to go back and solve for y. So I know that x is equal to 6. I'm going to take my x value, plug it into the equation, and solve for y. So in this example, I'm going to plug in my x value back into the first equation so that you can see that you can use any equation to plug in the x. It's just that the first equation is a bit longer to solve, but that's okay. Let's just do it as an example anyway. So y is equal to 3x plus 6. Y is equal to 3. I just solved and found that x is equal to 6. So 3 times 6 plus 6. 3 times 6 is 18 plus 6. That is 24. So y is equal to 24. If you had plugged it in to the second equation right here, if you did y is equal to 4x and you substituted the 6 for x, y is equal to 4 times 6, which is 24, right? So it doesn't matter if we substitute into the first equation or the second equation, we would still end up seeing that y is equal to 24. Okay, so then our solution for this system is 6, 24. Okay, so that's how we solve a system of equations by substitution when they are both in slope-intercept form, right? When they're both in y equals, all we have to do is set the two equations equal to each other, right? So that's what we did in all of these, right? We took the expressions, these two expressions, and set them equal to each other and solved. All right, cool. I hope that was helpful a little bit.